Hello, Mr. Minnick, helping students with tracing code worksheet number 2. It's an AP Java class, AP Computer Science A exam. Always read the directions carefully. I do like the word error to be printed anywhere that there's an error. Sometimes I make errors intentionally, and you should explain whether it's a string index out of bounds error or some other kind of error that you're responsible for knowing for the College Board AP Computer Science A exam. And if there's a final answer that ends up being a string, I want you to surround it with double quotes. If it's an int or a double, don't put quotes around it. And for full credit, I always like to see some scratch work, some amount of scratch work. Okay, the first code segment. That works fine there, that line of code. I'm using a mouse, so I can't easily write in here. Plus, there's not enough room to write I love my dog here easily. So just pretend that blah, 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 I love my dog is written there, perhaps with double quotes around it to remember that. Now, the next line of code. Whatever substring 7 returns when being applied to the variable named dog, that's what we store in dog2. So substring, it's this method you could look up in my notes or online at oracle.com in the Java API. When there's one parameter, like the number 7 in the parentheses of the substring method, that means to go to index position 7. When you're counting index positions for strings, you start with 0, and then you number these, and perhaps you show this with scratch work so that I know that you understand this when I grade this. But anyway, if you were to count to position 7, that would be the character, the letter D. And that substring parentheses 7 means start at position 7, where the D is, and then extract or take everything from that point on. So the variable dog2 stores the string literal value dog. Maybe you're the kind of person that puts quotes around it in your scratch work, just to be careful so you know there's not a space in front of the D or after the G. And now we simply system out print whatever dog2 is. And so the word dog right here prints out. But I do want, as specified earlier up in the directions, I do want a little set of double quotes around this so that I know that you know that that's a string. Like say the zip code in the local area where I live is 19610, not pronounced 19,610. Okay, exercise 2. Even though num, the variable name, makes it sound like it's a number, it's really a string that gets initialized from right to left into a freshly declared string variable. So 5.8 should be printed here on your scratch work. And if a teacher or a professor doesn't make a little area for your scratch work, then you should make columns somewhere on the margin of the paper. Okay, 7 is stored here, but that I would not put double quotes around that because that's an int and not a string. That's a primitive int variable, and so is num3. What the heck? Parse int? Well, go look it up in the notes or online in an API if you don't know what it means. So num, which is a string, 58, inside the parentheses here, parse int strips the quotes off of the 5.8. I should pronounce it 5.8, not 58. Parse int takes away those quotes. And parse int is a static method from what we call the integer class. It's just handy to know this for the AP exam and beyond that. So we now have all of this simplifies to just the straight up number 58 without double quotes. And that is legal to mathematically add that to num2, which you can see is 7. And that's 65. So 65 is the final number there on the right-hand side of the equals. That 65 is being plugged into num3, which is a legal int variable. So 65 is what you would write here under that part of scratch work. Order of operations, well, the next line of code actually. Num4 equals num3 minus 2. Num3 is that 65. 65 minus 2 would be 63. 63 plugs in there. And I like to see this scratch work. System out print num4. Num4 is currently 63, so there's your answer without double quotes because num4 is an int and not a string. In number 3, be very careful. I have a double, I have an int, and another variable named f. That's an int. Well, j is 1. That's pretty easy. It's a whole number 1. K is equal to 1.1, and that is legal because k is a double and not an int. If k were an int, that would be problems. Look it up, test it out, figure it out. Anyway, it's not a problem. Now, this third line of code, very, very, very tricky. We execute the code on the right, simplify it, and attempt to store it into the variable name waiting on the left. That's how it works in computer science. So first we have to do k plus j. Well, in Java, you can add whole numbers with decimal numbers. You can add ints and doubles and get away with it without an error. So there's no problem in the addition there. That addition would come out to 2.1 with accuracy. But the attempt to plug or initialize or assign 2.1, the value, into f, which doesn't have a backseat in its car. It's a sports car, it's an int. It doesn't have the 0.1 availability to store the 0.1. Sorry, that 0.1 can't fit. In some computer languages, it would truncate. In some languages, it would round, if it were like 0.5 or higher. Anyway, in Java, you just can't even do this. You can't try to do this. It's an error. I'll let it up to you to look up what kind of error it is that you should fully explain here, but there's an error there. So you can supply the rest of the explanation. It is something that's you're held accountable for on the AP exam, to carefully trace code and not just hurry on worksheets and think that f plus 2, which you might think is 4.1, because 2.1 plus this extra 2 would be 4.1, but it's not. Okay, exercise 4, you end up with index of D. What's index of do? Well, index of finds the letter D, the character, I should say, D, in the string phrase. So after you write your scratch work down here, that first D is in position. You start at 0 here, 0, 1, 2, 3, 4, 5, 6. If my counting's right, that's position 7. So the number 7 plugs into the variable pos, which is short for position, I think. And that 7, because we work inside the parentheses out, plus 2 mathematically works out to be 9. I'll let it up to you to write the answer there without the double quotes, because that is not a string. That's just a plain old number. 7 plus 2, 9. Number 5, very tricky. You're supposed to know these two constants for the AP exam. Now, they are on what's called the College Board Quick Reference. I call it the cheat sheet. It's also in my notes, and you can Google it. But when you type integer.min value, that's the smallest, most negative number on the number line that you're allowed to use for integers in Java. And this is the biggest number, max value, that you're allowed to use. Now, sometimes these numbers change behind the scenes when processors or Java standards are upgraded. Back when I was your age, min value might have been like 16, 2 to the 4th power. But now it's like, well, 2 to 30, the 32nd power, negative, maybe? Look it up. It's explained in my notes. And look this up. But when you have a bunch of British redcoats on this side, min, fighting a bunch of Revolutionary War Continental soldiers here, and they shoot each other in a one-to-one way. I shouldn't talk about shooting. So when you cancel things out, I think you're left with one extra min. I think num ends up being -1 and not 0 like you'd think they'd cancel out. So try it out. I'm not going to give you the answer to that, but it is doable. This one, caret, even though it's not covered on the AP exam, you start counting at the positions at 0, and position 3 is where the 4 is stored. And that ends up being a string. And it ends up being just one digit. Well, that when you do char@ 3. So I think it's a 4, but with double quotes around it. Now I'm saying that in this video, but I'm not going to put the answer down that way. So we'll see how many people are listening to this worksheet to know that the char@ method from the string class returns a string, and therefore it ends up being a string answer. Ooh, this is a overflow. You're going over the end of integer max value. What happens? Do you sail off the earth and never to be seen again? Or does it wrap around and come in the negative end of the number line? There's an int number line in Java, and out here is integer max value, and right here is integer min value. If you add 1 to the edge of the earth right here, I think it wraps around and you come in here. Now that's mean. Somebody who has $2 billion or so dollars, you give that person one more dollar, and they have now negative $2 billion. It's weird. Not that you would ever do this on purpose, but you should look it up in the notes. I explained it very well in my lecture notes. This one right here, very tricky. One year I gave this worksheet, a lot of people missed it. There's a round method that's built into what's called the math class in Java. And when you multiply 100 times f here, you're moving the decimal 2 places to the right. So 435.6 rounded. Don't think about this too long. But if you have to, look up the round method to see how it works in the Java API. But you know what? I think it turns out to be 436. Just saying. But I'm not sure. So look it up. And when you turn that into a whole number, it's still 436. But this is an example of casting, and you're turning this double, which is really the number 436.0, and you're purposely taking that 0 and you're truncating it because of the casting operator called int. If you didn't do that, you'd probably get an error message because the attempt to put 0.0 into the back seat of a car that doesn't have a back seat, again, this is an int, not a double. Even if something's 0.0, it's not allowed to be stored in n unless you do this thing called casting, which is covered in my course. It's in the lecture notes and previous videos. So I think the answer is 436 and not an error. But people that watch videos should still have to look things up. Hey, number 9. As soon as you see something like this, you should smell a trick. Tricky. The AP exam people love to do this, and sometimes just out in life in the coding world, other coworkers do this by accident. You got to be able to spot it. When you have an int divided by another integer whole number, it chops off the decimal places. So 9 divided by 2 in math is 4.5, but when you use the / in computer science, especially Java, that 0.5 is chopped off. So bye-bye, occupant of the backseat of my car, bye-bye. Only 4 is now stored in the variable result, even though it could have accommodated somebody in the backseat in the decimal places. It's not. It doesn't make it there. It gets chopped off according to order of operations when this simplification occurs on the right-hand side of the equals. Now the computer, when system out printing it, might print 4.0. But I'm happy on this worksheet if you just have 4. Don't put the 0.5 there, and certainly don't round up to 5. That's nonsense. It would never round unless you're using a round method or some other technique that's explained in my notes. Now number 10, this is like a favorite of the AP exam, to do this kind of stuff all jumbled together in one system out print statement. Now if you work out the order of operations here and realize that num is equal to the number 123, 123 mod 100, you should not have to think about that too long. My students here in Pennsylvania know that when you mod by 100, you're really parsing or extracting the 2 rightmost digits from the right. In other words, 123 divided by 100 leaves a remainder of 23. It just always works. So this right here simplifies to just plain old 23. And according to order of operations, you do mod before plus, and plus you're working left to right. When you mod by 10, the original num, 123, that's really just quickly extracting the ones digit. So that simplifies to 3. And 3 plus 23 is 26. Oh, but stop. This 23 needs to be divided by 10 before that plus. And 23 divided by 10, because it's integer division like we experienced up here, you're chopping off that 3 and it's turning into just 2. Because 23 divided by 10 is 2.3, but because it's integer division, you're chopping off the 3. So this simplifies to 2, and now we have this plus and this plus, and we work from left to right. This 3 plus this 2 is 5. And we're still left with 5 plus whatever all this is. When you mod by 1,000, similar to modding by 100 and similar to modding by 10, you're taking, in this case, the 3, because you have 3 zeros here and not 2 zeros like you had in 100, you're taking the 3 rightmost digits of 123, which is essentially the whole number. Now, if it were like 5,123, the 5 would be effectively removed and we'd be left with 123. Anyway, all this simplifies to 123. /100. Well, when dividing by 100, you're moving the decimal 2 places in from the right. And you would think it's $1.23. But because it's 2 integers being divided, again, like we saw up here, we're chopping off the 0.23, and all of this simplifies to the number 1. And we're left with 5 plus 1, which is 6. And I'm not going to write the final answer in. Nobody's going to scroll to the end of my video and get free answers without listening to this important explanation. Have a great day. Looking forward to a happy, successful, probably well-paying job without threat of being fired or laid off if you go into the world of computer science in 2018. And if you know how to do this worksheet.